Hello and welcome to the video Square Roots, where we learn to simplify square roots. Below are the steps listed. We will be illustrating these steps as we go through our example problems. So, let's get started. Let's say I want to find or simplify the square root of 20. Well, step number 1 says I need to complete the prime factorization. So, I'm going to find a product of this number 20, which is 4 times 5. Now 4 is not a prime number, so I can find a product of that number, and that's 2 times 2. And 5 is a prime number, so I'll go ahead and bring that down. So the square root of 20, we get the prime factorization of 2 times 2 times 5. Step number 2 says we need to group the correct number of matching prime numbers as indicated by the radical type. Well, what are different types of radicals? In the first example, we have a square root. The square root is the only sign whose type can be omitted. It's understood to be a square root. If we want to write the type, we will write a 2. The cube root and all the other roots, type must be written so you can distinguish between that type and a square root. So this is a cube root and this is a fourth root. And it goes on and on and on. Now, the purpose, or one of the purposes of the type of roots will indicate is the number of identical numbers needed to make a group. So, for a square root, you need 2 identical numbers to make a group. And for cube roots, you need 3 identical numbers to make a group. Catch the pattern? How many identical numbers do you need for a fourth root? Well, that's right. You'll need 4 identical numbers for a fourth root. So this goes on and on and on. Fifth root needs 5, so on and so forth. So in our problem, we have a square root. So we need to find 2 identical numbers that are the same. So we have one group here of 2. Step number 3 says we need to write these groups outside the radical expressed as powers. So the power or exponent will indicate how many groups you made, and the term or base number will indicate the type of group. So I have one group of 2s. So we'll write what's left inside the radical, which is 5. Step number 4 says multiply the numbers outside and inside the radical respectively. If we had more than one group outside, then we'll multiply those numbers together. If we have more than one term or number inside, we'll multiply those numbers together, and then that will be our answer. But since we don't, the simplified version of the square root of 20 is 2 square root of 5. Let's look at another example, 50. Now, first step is complete the prime factorization. So this will be 2 times 25. And 25 is not prime, so I can find a product of that, which is 5 times 5. And I'll bring down the 2 as prime. So now, the square root of 50 is 2 times 5 times 5. Step number 2 says we need to group the correct number of matching prime numbers as indicated by the radical type. So, we have squared, so we need 2 identical numbers to make a group. So, I see one group of 5. Step number 3 said we have to write these groups outside the radicals expressed as powers. So, I have one group of 5, and what's left inside the radical is a 2. So there's nothing to multiply outside, no multiple groups or multiple numbers inside, so our answer is just 5 square root of 2. Let's look at another example. Let's find the square root of 72. Well, the first step, prime factorization. So, what product makes 72? 9 times 8. So, 9 times 8. 9 is not a prime number, so we can find a product of that. 3 times 3. And 4 is not a prime number. So the product of that is 4 times 2. 2 is not a prime number, and that product is 2 times 2. So we'll bring down the 3 and the 3 and the 2 because they are all prime numbers. Now, square root of 72 is prime factorization is 3 times 3 times 2 times 2 times 2. Now, step number 2 says we need to group according to the radical. We need to find the correct number of matching prime numbers as indicated by a type of radical. So we see, hey, there's one group of 3 here, and there's another group of here, which is a group of 2. So that's all the groups I can make. So now, step number 3, we have to write these outside the radical, expressed as powers. So we have one group of 3 times one group of 2. And what's left inside the radical is a 2. So we have more than one group out here, so we'll multiply these together. So 3 times 2 is 6. And 2 is left on the inside. So our simplified answer is 6 square root 2. Now note these exponents. 3 to the first is just 3, and 2 to the first is just 2. So 3 times 2 is 6. But if this was a different number, like say squared, then 3 squared would be 9, and it would be 9 times 2. So remember your exponent rules. Let's simplify the square root of 110. So let's find the prime factorization. And this would be 55 times 2. And we can break down 55 into 5 times 11 times 2. We'll bring that down. So the square root, the prime factorization of the square root of 110 is 5 times 11 times 2. Well, when we look at this example, we have no identical numbers enough to make a group. So therefore, our simplified radical was what we started with, square root of 110. Let's look at another problem. Problem will be the square root of 360. So step number 1, let's complete the prime factorization. So one factor is 36 times 10. And then we'll break down the 36, be 6 times 6. And the 10 will break down to 5 times 2. So these 6's will break down to 3 times 2 each. And we'll bring down the 5, and we'll bring down the 2. So the square root of this number will be 3 times 3 times 2 times 2 times 2 times 5. So now we need to group the correct number of matching prime numbers as indicated by the radical. So we have a square root, so that means we have to find 2 identical numbers to make a group. So here's a group of 3, and here's a group of 2. So let's write these groups outside the radical. So that'll be one group of 3 times one group of 2. And what's left inside the radical is 2 times 5. So we have 3 times 2, or 3 to the first is 3, times 2 to the first is 2. So 3 times 2 is 6. And what's left inside the radical is 2 times 5, and that's 10. So our simplified answer is 6 square root of 10. Thanks for watching. And remember, math is just making amazing thoughts happen.